My name is David Chenault, and I'm with Polaris Sensor Technologies. We're in Huntsville, Alabama. We're primarily an R&D firm. We do a lot of custom sensor development. We have a focus in polarization imaging sensors. We have also recently gotten involved in 3D displays and stereo vision systems, in particular for unmanned systems and for teleoperation. We started with 2 people and a couple of SBIR grants, and we have grown to 25 people over the last 5 or 7 years. And in many ways, I would say that we are kind of poster children for the SBIR program, because we have taken technologies from the SBIR program that we've developed as part of the SBIR program and taken them nearly to market. We've also taken those technologies and transitioned those to a lot of different other contracts. About 1.5 years ago, more than half of our contracts were non-SBIR programs, largely based on the SBIR technologies that we had developed previously. We have a suite of sensors based on various architectures, depending on the particular application. If you're looking for a phenomenology-based sensor, we can produce a sensor that is a little cheaper, but it involves rotating parts, which is less desirable for when you want to place your sensor on a moving platform or when you're looking at highly dynamic targets. The variety of architectures that we have take advantage of optics and MEMS optical components, as well as moving parts, and we just select the right one for the application. We have found that for polarization sensing, long-wave sensors or long-wave signatures, polarization signatures are a good bit more robust than they are in the mid-wave. Of course, the signatures are dominated by emission. It turns out that in the mid-wave, when you have both emitted and reflected components, the polarization signatures tend to cancel, and they're not as robust through a diurnal cycle. We have sensors at Picatinny Arsenal that are currently on a 2-year, every 5-minute data collection cycle, and so we're getting data through the diurnal cycle, through the seasons, and in all kinds of weather. And to date, we have found that in fact the long-wave signatures are the most robust for polarization. The primary application, of course, is for target detection, looking for man-made objects in natural clutter. Polarization doesn't always have the best solution, but it turns out that with a polarization sensor, you also get the underlying intensity imagery as well. And so in those cases where polarization doesn't work as well, frequently the intensity does, and vice versa. There's a lot of times when the intensity signature is very low, and frequently the polarization signature will be very strong. There are definitely new types of detectors, and we're working with a couple of them. We have put together some pixelated or division of focal plane type polarization sensors, but we're also currently working through funding with AFOSR on some of the new quantum dot focal plane arrays and trying to introduce polarization sensitivity to those types of detectors. We have 2 versions of 3D displays. One of them has been specifically designed for operation or application to the live video situations, like in a robot where you're doing teleoperation or manipulation with the robot, and that's specifically for analog video that is real time. And we have integrated that into a Talon robot and performed these military user assessments and tests with soldiers with great success. The other type of display that we have is designed specifically for computer input. So any kind of computer content that has 3D information or recorded stereo video can be played on these monitors. These are more designed for higher resolution, higher format type applications. In fact, what we're showing at the show here this week is a 1920 by 1200 format, high resolution 3D display. There are definitely challenges in putting together a good polarization sensor, particularly in the infrared, and we have developed the expertise and the tricks of the trade, I guess, to put together a sensor that gives good accurate imagery. We've done that over a large number of years, and that's one of the reasons we are kind of known in our niche, I guess.